Any other questions? Oh, subjects. That's a great one. Yeah, so let's talk a little bit about subjects. A subject is a great example of how we turn observables into hot observables. So subjects are an example of a hot observable. And what they do is it's actually a really elegant, beautiful abstraction. They take the two interfaces we have in observable, observable and observer, and they smush them together into a new type called a subject. So the best way of teaching you guys about subjects is actually just to go back to our custom observable implementation and implement a subject. So a subject inherits from an observable. So let's make ourselves a subject. Subject is basically a way in which you can broadcast a value to multiple listeners. So you remember we talked about why we might want to set up an observable such that every new subscriber gets their own network request, for example, right? So, but sometimes you want that behavior, like for retry, but sometimes you don't want that behavior. Sometimes you might want to have 5 concurrent subscribers all just listen for the result of one network request. So how do we achieve that? Well, I'm going to create a subject. The subject extends an observable. And all a subject does is it internally just keeps a list of all of its concurrent observers, and every single time you call next on a subject, because remember, a subject is both an observer and an observable, when you call next on a subject, it just loops through all of its observers and calls next on all the observers. Does that make sense? So it's a mechanism for what we call multicasting, or broadcasting a message to multiple concurrent subscribers without repeating the side effects like issuing a network request or starting a timer for every concurrent subscriber. So let's see how we can use a subject to take something like set timeout or a network request and set only one timer for a whole bunch of different users. Make sense? So a subject looks like this. Instructor and super. The definition of its subscribe is quite simple, actually. This is a good opportunity to use map. So when you subscribe to a subject, it just takes the observer, puts it into an array. That's all it does. And then I think this is delete, but I'm gonna, as you guys are gonna see, I'm gonna set up a set, which is gonna be used to store all of the observers I have. JavaScript set. Does that make sense to everybody? So all we've done is create an observable that whenever you subscribe up to it, it just says, oh, thanks very much, I'm going to take that observer, I'm going to put it in a set, and I'm just going to chill. Okay? So as I said earlier, a subject is actually a combination of an observer and an observable. What are the 3 methods on an observer? Anybody tell me? On an observer?
Next, complete, error.
Next, complete, and error. So when next is called, I'm literally just going to loop over all the observers. I'm going to call next on them. Anybody want to take a guess what I'm going to do if error is called?
Loop over all of them and call error.
Yep. So what have we really accomplished here? I mean, we're just like a repository for a bunch of observers, and then whenever anybody calls next, we just broadcast it to everybody. Why is that useful? So same thing with complete. So it's actually very rare that you'll use a subject directly. However, the principle of broadcasting the result of an observable to many consumers is very important in RX, and usually you'll use operators that internally create subjects, like share and replay, for example. So if I have an observable, like the timeout observable we created earlier, where it's going to trigger a new timer for every concurrent subscriber, I can use the share method to basically make sure that no matter how many concurrent subscribers, they're all going to share the same timer. And under the hood, all share does is it creates a subject. It subscribes the subject to the observable because the subject is an observer, and then it subscribes all new observers to the subject rather than the source observable. That was a lot of talking real quick, but we're going to take a look at how that works. And there's one little detail which is important. If I don't do this, I open up the possibility that when I next an observer, they unsubscribe. And if they unsubscribe, they're going to remove themselves from the set while I'm iterating the set. And that's not a good thing. So I quickly make a copy of the observers, and then I make sure I don't have that race condition. So does everybody see my subject here? Wasn't that hard, right? We built a subject. Pretty straightforward. All we're doing is socking away observers, broadcasting messages to them. So now let's see if we can write share, the share method, so that we can take our timeout observable and just instantiate one timer, just start one timer for every single subscribe to the observable returned from timeout. Now notice here, every single time somebody calls subscribe, we're going to kick off a new set timeout method, right? Because it's right there inside of subscribe. How are we going to rig it up so no matter how many subscribers, we only get one call to set timeout? This is a very important trick. It's used all the time because very often you don't want to kick 5 of the same network requests off at the same time, right? That doesn't make a lot of sense in a lot of cases. So I'm going to write myself a function called share. You can take any observable and you can share it. Under the hood, it's going to create a subject. And it's going to go self.subscribe subject. Or wait, so yes, and then it is going to, oh, I forgot, sorry, I got to return a new observable because that's what share returns. Did I do this right? This is not 100% right, but it's pretty darn close. Does everybody see that? See what's going on there? I'm cheating. This is not exactly how share is implemented, but that's the basic concept. And let's go back and take our timeout observable. Did I break that? Oh, good. Just took a second. Remember that timeout just on next undefined. That's why we see undefined there. Right? Now if I take... Now, just to make sure this is working, inside of our timeout observable, when we call set timeout, we'll log to the console. Now I'm going to take this timeout observable, I'm going to assign it to a variable, and then we're going to call subscribe, but this time we're going to call it twice. And we expect that with each call to subscribe, we're going to get a new call to set timeout, right? And sure enough, we do. What we're going to try and do with the share operation is we're going to make sure that only one call happens to set timeout. And again, this is less useful in the context, actually it could be useful in the context of set timeout, and more useful in the context of network requests, right? Where I want one network request to be kicked off no matter how many people are listening. So let's see what happens when I go .share. Well, it breaks, but we'll figure out why. Self.subscribe is not a function.
149, this equals self.
Where do you see that?
149.
Is it complaining about 149?
Right there, ensure share.
I think you want
Oh.
underscore subscribe.
I actually want this right here because this is a instance method. So we call share on an observable, and so this in this case will be the observable. So let's give that a shot. Uh-oh. Right, it's not observers, but this dot observers. Hmm.
172 and 172.
Is it 172?
As
Ah, there we
is.
go. I'm going to get the hang of this JavaScript thing one day. It'll be great. And, oh, right, because sets aren't arrays. Still getting used to the fancy new JavaScript stuff. I think I can do this trick, though, because sets are iterable. I love this new ES6 hotness. There might be a better way of doing that, but that's what I'm going to do for now. There we go. Do we all understand what really happened there? Right? We created one observable, so we got this link of chains of observables calling each other, right? And we created one link in the chain that'll just store up multiple observers, and then instead of just going up, when we get to that step in the chain, it'll broadcast it to all the observers. And that's the key to how we make sure that if we've got an observable that we don't want to be lazy, we can make it eager, in this case, and share the side effects across multiple consumers. Now, once again, I'm hand-waving a little bit. The real definition of share is a little bit better than this, a little bit different than this, a little more complex, but that's the basic idea. So now you guys understand subjects. That's pretty much all there is to it. There are variations of subjects like replay subject and behavior subject, and they're probably worth talking about, but the reality is you're not going to use them directly. In all likelihood, you're going to use methods like share and replay. So share, we just learned. Anybody want to hazard a guess as to what replay does?
Replays what was previously nexted.
So one of the dangers around hot observables, which is what subjects are, is you might miss something that you wanted, right? Depending on when you subscribe to a hot observable, you might get a different result. And so sometimes what you want is you actually want, so let's say we create that observable that represents the network request, and 15 people subscribe to it all at once, and then they all get the same network request, and we only issue one network request, but then 2 seconds later, somebody comes along and subscribes to that observable again. Well, we might want to kick off yet another network request, or we might just want to store up whatever the result of that network request is and just hand it to them. And that's what a replay observable is. It replays the observable for folks who come late to the party. Does that make sense? So after we've already played, that's all it is, and it's instead of share, it's a replay. And these are the two methods, and under the hood they use different variations of subjects, a replay subject and a regular subject, but these are the methods that, and these are how these methods work. Under the hood they just use a subject. So now I'm glad somebody asked about that because we've come full circle. We've talked about the benefits of laziness, but we've also talked about how we can make something not lazy anymore in order to share side effects across multiple consumers.
So in that replay example, where somebody comes late and you want to give them that, you don't replay it for everyone?
The idea would be, so let's say 3 people come and subscribe to an observable, right? You make one network request because it's a shared observable, and then you on next and then on complete all 3 of them. They all go away because they've been on completed. Now what happens when somebody comes along, right? Would you want to kick off another network request? You probably do, right? Because that person needs data as well. But if you're confident that the network request is just going to give you back the same data, like let's say it's a request for, I don't know, some company's privacy policy, or at least that's not going to change very often, right? You can just cache it in memory and then hand it to them, and that's all a replay subject does.
It's like hanging on to a resolved promise and just giving them back.
Exactly. A promise, so actually that's worth talking about, because a promise is like an observable that's always hot, it's always like a subject, and it always caches. So a replay subject basically turns an observable into something very similar to a promise, except it sends multiple values instead of one value. So promises have that behavior all the time. They are always hot and they always cache their results. So if you come after a promise is resolved and say, hey, give me the result, the promise will just immediately call you with whatever result it has cached. Does that make sense? And so we can see that observables are more primitive than promises. You can build a promise by combining together methods on an observable until it behaves exactly like a promise. But you can't go vice versa. You can't build an observable on top of a promise. Right? Because you can always go from lazy to eager, but you can't go from eager to lazy. Once you've started the work, you've started the work. So it's a very flexible and powerful primitive.